So out of this 2.5% of all the water on the planet, about 78% is in the ice and the glaciers. No wonder melting of those ice caps and the glaciers play a very profound role in the climate change. And if we look down here, groundwater 21%. Well, we cannot go directly to those ice and glaciers to get water, can we? No. They have to melt down to water and see how big portion the groundwater is. I put a drop of water here to get your attention because this is one of my focuses. Is very interesting. I think a lot of people will be very interested to know more about groundwater. It's buried underneath doesn't mean they are not important. They are very mysterious and they are very fantastic. You will encounter new challenging concepts. That doesn't mean rivers and the lakes are not important. It's 1%, but it's still significant. And about 0.5% is in the soil, is retained by the soil. So that's how amazing soil is. I want you to go page 348 to read this one page article, Who Owns the Water? Because we all need water for everyday life. People have arguments where they come from, who owns them. And my two interesting questions here, I want you to put them in your mind when you read this article, is how long can the battle over water be? And is current path of usage sustainable? And keep thinking about those questions when you read through this page. And the people in some area of the world, people fight over water, and they use wars, and they use water as a weapon to control. And so there's new international laws to forbid to use water as some sort of weapons now. But water can stir conflicts because it is precious. The global water challenge. Look around the whole world. We have rising demands because of rising of the population, and we need more pure water, high quality water, not just the quantity of the water, but the quality of the water also. And we'll suffer more droughts because of the global warming. And we have challenges to supply water without degrading the natural ecosystems that provide it. This is where the science and technology play very important role. We need to know the land features. We need to know the features of the water, and we need to know where they come from, where they go. And we will try to honor, to sustain, maintain the nature's arrangements. And we don't want to disturb them too much. How scarce can water be? This is a picture. This is some people in India waiting at this, around this well, trying to get water. So this slide is the study slide. When I put the study slide, that means there's a lot of details. If you're interested, just read them, and that save your time in reading the textbook. Here I just want to highlight my points here. The potable water is unpolluted fresh water, suitable for drinking. Quality is as important as quantity. And WHO estimates a quarter of the population does not have access to safe drinking water. And it will become worse in the next 20 to 50 years. 5 to 10 million deaths worldwide each year due to various diseases caused by lack of safe, pure, clean enough water. And these illnesses have been increasing over the past decades and will continue if the water issue is not solved. So this is a map nowadays how many countries are under stress. Those red color area is the worst. You can see it's around Africa and close to equator because it's hot. Those blue areas and the light blue areas are okay for now, but if you look at 2040, those areas are not okay anymore. The European, Asian area, North American area, especially America, and even Australia will suffer some sort of distress. Now, hydrologic cycle. If you look at how water flows in the nature, it could be a lot of arrows here, right? A lot of ways, and you can talk about those arrows like ever and forever. But if we go back to our slide here, I just want you to know two things. Okay, one is, probably three things. One is evapotranspiration. That is a process of plants giving off water. And also, this is part of the evaporating part. So the water go out, okay? It's driven by solar energy. It means it evaporates. It gained energy. The ice melted into water, and the water separates, and they go into the air. And another process is precipitation. So it go up and it go down. So it go into the nature, right? They separate it, they go into the nature, they evaporate, and then they come back to the surface of the planet. So those are the two key concepts. And this whole cycle, hydrologic cycle, is driven by solar energy. As I mentioned before, all energy comes from the sun, and now sun drives the water cycle. So runoff is the surface water that moves across the surface of the land and enters streams and rivers. And the groundwater is the water that fills space in the substrate. So what is a substrate? The substrate means gravel, sand, rocks. So groundwater is soaked in those substrates called aquifers. Think about that. Think about mineral water, where the mineral come from. From the aquifer, right? So what are aquifer? A blend of gravel, sand, and rocks. Now I want to challenge your way of thinking. What is purity and cleanness of water? What is healthy water? Actually, the healthiest water comes from the rocks, gravel, and the sand, from the earth. It has a lot of tiny amounts of nutrients in the water, and which is vital to our health too. So the cleanest water actually coexisting with our earth is in the soil, buried deep under the soil. What is unconfined aquifer? I will test this in my test and in my final exam. The top layer saturated with water is a water table, and this unconfined aquifer primarily recharged by rainfall. Unconfined means goes in and goes out without being confined. And the confined aquifer is a water locked between the two layers of impermeable rocks. And the semi-confined means there's one way out, one way in, but